So thank you everyone for joining today's session. Our topic today is adopting ethical AI for impact in the global south. It's a bit of an abstract concept. When we started exploring this from Acme AI, I'm Sadhli, by the way, from Acme AI, and I have a bit of an introduction about myself before we get into things. I'm a creative technologist. I have around 10 years of, a bit over 10 years of experience in digital development, policy, and innovations, centralized in South Asia. Particularly in Bangladesh, working in public health, precision agriculture, technical and vocational education, and working with the government to essentially streamline their services through integration of technology. I have worked with, organizations such as World Health Organization, the WHO, UNICEF, Google, ADB, Gain, Care, and Telenor, and a mix of other private sector entities as well in South Asia and Bangladesh. I am a postgraduate in digital humanities from the University of Sydney. This was back in 2020. And I was, due to return to my country back in 2020 when tragedy hit. That tragedy was COVID-19. It completely destabilized the Bangladeshi and the global economy and pushed me and my family to the brink. So there were times like I was worried whether or not I can put food on the table. So it was like that for us. And Acme AI during that time was born both out of necessity and as well as from a class project. So Acme AI is we started out as an AI data solutions provider and have since then migrated towards providing custom solutions in AI and provide expert resourcing solutions for AI giants based globally. We work in a variety of sectors, as you can see on the right side of your screen. So health and well-being, agriculture, supply chain, self-driving cars, manufacturing automation, robotics, deep analytics of sports, as well as livelihoods development. We work predominantly with companies in the global north, so in the US, UK, and the EU, and some parts of Oceania, to essentially provide services for their own machine learning models, to fine-tune them, so to speak. These are some of our partners. I'll just breeze through them. So yeah, getting back on topic, adopting ethical AI for impact in the global south. Before we get into this, we often see from our clients or students or even people we engaged with, is that there is a bit of a gap in understanding in terms of what AI is. So what is AI? It's basically a replication of human intelligence that is designed to augment certain things. So a crude simulation of human intelligence, so to speak. You might have seen in the beginning of the presentation these three icons. These three icons basically represent three different areas where the global AI discourse is currently converged on. The first icon represents vision, your eyes. The second is text, things you do in ChatGPT, and the third is audio. So acoustics that reach acoustics from where people can essentially recognize patterns. AI essentially does just that. It recognizes patterns, and based on recognizing those patterns, they provide some kind of output or feedback. And since we're talking about ethics, ethical AI basically works with certain pillars. The three pillars are essentially fairness, transparency, and accountability. We're going to forget about these pillars as of now and go into a more practical way of understanding things. We'll come back to that later. So to get a bit of a deeper context, this is a self-driving car. From the image itself, I counted before coming into this presentation, there are 17 cameras installed just in the front side of the car. We can't see the back side yet. So it's more than 17. So self-driving cars essentially work through vision. So these cameras serve as their eyes, and based on the visual data that they receive, they essentially make decisions. Algorithmic construct that is embedded inside of these cars make decisions on how to navigate. The way they perceive the world, we don't perceive the world the same way as this car do. The way they perceive the world is like this. So they identify everything from lane marks to stop signs to other vehicles, potentially the weather condition as well. It's a cloudy weather and whatnot, and a lot of different things that basically helps them understand the difference between a pedestrian and open road, so they can drive safely without running over that pedestrian. So that's how a self-driving car algorithm essentially works. They see, they make sense, and then they navigate. Now, this is an image from the US. This is from an image from a Tesla FDS system, full drive system, as they call it, and how they essentially perceive the world. This is an image from Berlin. It's, I think, the same, almost quite similar. Like they have roads, the lanes are essentially the same, mostly orderly traffic, if you could say, something like that. Now, I'm going to show you another image, and I would like your feedback on whether or not these like a self-driving car built for US or EU essentially would work here. This is an image from Bangladesh. So you can sparsely see the road. There are categories of vehicles that I think the Tesla models or the Waymo models don't even know, like what is a rickshaw or what is a three-wheeler auto rickshaw. Pedestrian or the street signs are essentially covered over by election posters and whatnot. So it's a different ball game completely. So yeah, it wouldn't work in a scenario like Bangladesh. It was just not designed to work in an environment like this. No self-driving car can work in Bangladesh, or at least in Dhaka traffic. Similar is in India, at least in places where traffic is quite chaotic. So key questions from this particular use case is that would the Waymos or Teslas of the world made for a very specific market work in a different market? What's the missing link? That's the question. Why would it not work in Bangladesh? So as you type in, I'll just go on to the answer. It's data. And let's get into like the deeper part of thing. It's basically representative data. So data is already fed into the model to work in the US and the EU, but Bangladeshi data is not added into the model for the card to essentially work in the realities of Bangladesh. This lack of data, lack of representative data, essentially bars interoperability of global AI systems into different markets. So ethics comes somewhere in here. We'll get into that, but way later. We'll talk about ethics a bit later, so that we don't want to like push you into all the doom and gloom of ethics from the get-go. So let's flip the coin a bit. We talked about self-driving cars, North America, Europe. This is a project that we did with the patronage of the Gates Foundation back in 2021. It's basically the system is called Bovie Matrix. It's basically a smartphone-based system, a smartphone-based app that works through machine learning to essentially detect cattle weight. So cattle weight is the foundational metric that you need to essentially assess the right amount of cattle inputs, which is feed or medicine. So if you feed a cattle more than they need, you would essentially incur more feed costs or medicine cost for that cattle. If you give them less than what is their weight or what is appropriate, they would essentially stunt in their growth, or the disease that they're suffering from would not go away because of low dosages. It is it is developed specifically for Bangladesh's grassroots livestock, smallholder livestock farmers, and for the paravets that work in our environment. So who are basically diploma veterinarians, who basically work to provide services to smallholder livestock farmers in Bangladesh, who are like vast in terms of their numbers. And also a tertiary use case that came up later on, which was essentially pricing. So cattle price is based on whenever the smallholder farmer essentially goes to a market to sell off their cattle, they don't know the weight of it. They're essentially at the mercy of the buyer, who are more influential in terms of their monetary influence and whatnot in the market. They guesstimate the price. So, oh, your cattle is 100 kilograms. I'm going to give you this amount of money. And the farmer is not like in a position to negotiate with that particular person, because they're not literate enough to essentially get an estimate of what their cattle is worth. So this system also gives you a volumetric weighing measurement from which they can essentially drive a better market access ecosystem. So it works in a very simple way. We had an app. We essentially take two pictures of a cattle, one from the side and one from the rear, and it essentially gives you a calculation of feed and medicine. And it essentially generated 92% accuracy. Weighing scales aren't available in grassroots Bangladesh, so in rural vicinities. So the only pathway of measuring a cattle weight is through a herd girth measurement. So the one that you can see on the small image on the bottom left side, it's a herd girth measurement. So you essentially tie a rope around the cattle and get that measurement. You need to have a minimal kind of literacy to do that, which the smallholder farmers do not have. The paravets do have that, some of them, and the people in the bazaars tend to have weighing scales that do not work. So, so they are at the mercy of guesstimation, regardless. So the problem here in terms of cross adaptation, this is a model that is developed purely for Bangladesh, trained on Holstein Friesian variety of cattle. That's a cattle breed, and it's crossbreed variety. Holstein Friesian cattle are essentially known for their dairy production capacity. So they provide good milk. So it's a bit of a valued breed here in Bangladesh. It's designed for smallholder livestock farmers, livestock service providers such as paravets. So my question is this system unadaptable for other geographies, say, for instance, the global north? Question. The answer is no, it isn't unadaptable. So yes, you can adapt that into the global north through some tweaking. You can see in the three images in the bottom left one is pigs. Pigs in the export market, particularly, is a big use case for countries like Japan to essentially utilize this system, this weight measurement system en masse. Our original system was inspired through a Japanese system that the entity Technocross Group essentially developed back in 2014. So they're years ahead of us in terms of developing these technologies. The second picture is a stationary camera. You're not working through a smartphone. It's a stationary camera for open pastures. So you think of your the big farms in Brazil or South America, where thousands of cows or cattle are essentially there. In order to identify which cattle has a stunting tendency and address their feeding habits appropriately, you would need a system like this to identify cattle as well as calculate their weight and inform farmers to essentially, or farm workers to essentially go to those cattle and provide interventions early. The third picture is from an export processing zone of Australia that we are working with. So they have installed overhead cameras. These cattle essentially go through a line, and the camera essentially take their measurement as they process from that line and into a ship where the pricing is essentially determined. The prior way of doing this was to essentially pull a cattle to a weighing scale, the stress of which essentially led to 2% loss in their body weight or the body mass index. So in just that small bit of struggle, these are big animals. They could essentially extend or lose up to 2% of their body mass. That could affect pricing and the profitability of the state. So LifeCorp from Australia, their livestock research arm, the government's livestock research arm, are essentially working towards that. The thing that Stephanie was talking about in terms of AI to amplify, this is the project or the prototype that we have built from that. And since we're talking about cattle before, I wanted to have a bit of a connector on what was the challenge behind us developing this menstrual health and hygiene advisory chatbot for women in the grassroots. So this came from a personal experience back in 2021. I was in the southern coastal region of Bangladesh, which is a climate hotspot, a climate hazard zone. So the woman you see on the right, Shushmita, it's an anonymized name. We are not allowed to provide her true name here. So 2 years ago, so around in 2019, she had her first menstruation, her first episode of menstruation, and she was essentially locked up by her family in a shed that they used to rear cattle in or store fiberwood in. This is the reason behind this is that menstruation or having period in Bangladesh, in grassroots Bangladesh, is often considered a sin. We are a very religiously and culturally dogmatic country. The region is very religiously and culturally dogmatic. There are certain stigma that goes on in these rural areas that disproportionately affect girls as opposed to men. This is what we call period stigma in general. This was the challenge area that inspired us to develop a system that democratizes menstrual health and hygiene education. Why did we do that? From social enterprises that worked in grassroots Bangladesh, there were studies that showcase menstrual health education in schools essentially translated into better outcomes for these girls. So as you can see, there are 30% of the women, 39 million menstruating women miss schools or drop out of schools right out due to periods. So we wanted to reduce that and put a dent in the legacy patriarchy that essentially fuels this cultural stigma here in Bangladesh. That's when we ideated using a large language model, same thing as ChatGPT or Gemini or the Claude that you work with or that you might be familiar with. We integrated that into a messenger app. So first we initiated in WhatsApp. We have gone out of WhatsApp currently and built our own standalone app. And then we deployed that application to aid workers that work in those vicinities to essentially promote this particular chatbot to rural girls, to school teachers, to parents, and we're a Muslim majority country, to mosques as well, where the religious leaders, the imams as we call them, they also promote the adoption of this app, not to only female adolescent girls, but to their male counterpart and guardians as well, who are also big influencers in these realities. The resulting impact is that we had over 6,000 users in our first month of beta launch. This was back in 2023, sorry, early 2024. And then we have since then secured funding from the Australian government to do a menopause iteration of this to deploy across the country. And then there are like pharmaceutical players who want to collaborate with us to promote their own product, for which they want to like engage in a profit sharing engagement with us. So yeah, that's about it in terms of the Probahini chatbot. We call it Probahini. Probahini loosely means flowing river. So it essentially in Bengali, so it provides a bit of an artistic symbolism on like we should not pause the flow of a river. It should go on. Barring the river is essentially barring equal opportunity, which is the river in this case is girls, representing girls, young women. And we should not put any bars to stop the flow of that river. So that's how Probahini was born. Now, this is the earliest iteration of a Probahini of the chatbot that we developed for health workers. Now, question, would it work for people in Berlin? Of course not, because language, as you can see, the language is foreign to you. So it can't respond in English in its early iteration. It could only respond in Bengali. There are training or AI data training bottlenecks that we faced in its initial provision, and period stigma just do not have a presence in the global north, particularly. So at least from like how it's widespread here in the global south, it's not the same in the global north. So there might be some pockets, but it's not the same. So there are cultural differences. So this Probahini chatbot in its earliest iteration would not be a very good fit for the global north or this cross-platform interoperability. To do that, we need to essentially address those language, AI training, contextualization, and cultural metaphors to essentially make it work in those systems. So, challenges in AI systems in its broad line, or as we have gone through the narrative as of now, are hallucinations and inaccuracy. They can provide very bad responses. They say like if you could ask an untrained AI like, hey, I'm having cramps in my tummy and my legs. What should I do? The AI system can just as easily tell you to kill yourself. So yeah, and that happened. And there are suicides attributed to these engagements. Particularly, there was this case of a climate change activist who did that. So, and there is a mass data poverty. Data mostly available in the global north are not essentially representative for adoption in the global south. Privacy and ethics are there. We're going to get into that in terms of medical use cases later on. And there are obviously lacking infrastructure. So server, digital spaces, cost of hosting, have different models, more heavy models, and those other things. So getting back into the academic side of things, the pillars that we talked about and that I basically brushed aside in the initial parts of the presentation: fairness, transparency, and accountability. In practice, they look at discrimination in terms of race, gender, geography, economic status. Explanation, we call it XAI, so explainable AI. So explanation of how a model works, which in most cases we don't know. The bigger AI companies do not know how AI algorithms work or how they evolve into a certain stage. It's a very dangerous concern that we have globally. but it is there. So transparency essentially directs to that. Accountability is that if there are like mechanisms built inside the AI for people to train them from a uh, democratized perspective. So you and I can train ChatGPT or Claude in fine-tuning their response. Do you have that system currently? You do, but you don't have an explanation on how that um, uh, uh, like feedback mechanism works in the real world. You can give a thumbs up or thumbs down in terms of the response, but that does not translate into training an AI that is customized or personalized for you. The most common areas of the most common areas of AI where it becomes unethical, so to speak, is gender and race misidentification, particularly in surveillance systems that are deployed across, say, for instance, China. There are certain parts of USA that are being deployed here, there as well, particularly in places where gun laws are very laxed, where there are cases of shooting, public shooting that happens, where you have, a surveillance system that are embedded with AI to essentially identify miscreants who carry a firearm. These AI systems misidentifies certain races as carrying a gun or prone to carrying a gun more as opposed to other races. So these kind of misidentification creates massive problems in terms of social in the social sector and in the social order, sorry. So generation of outputs that violates copyright. Most of you guys may know of this as you are generating artworks based on the previous class's representation. So there are artworks that have style copyrights that can be essentially misrepresented as copyright infringement. AI algorithms, particularly large language models or large action models, are trained with copyright violated systems. So the copyright violated data for which they output artistic representation that are not necessarily open for the public, or anyone cannot generate that. So a recent example is the Studio Ghibli movement globally that happened. So the founder of Studio Ghibli was not very fond of AI replicating their like artistic style to deploy that, but it was essentially decentralized to the globally. There are minority representation, generalization in terms of algorithms. Healthcare is the biggest sufferer in terms of unethical AI because one, health AI data is not widely available, even in the global north. So what happens, like developers of these AI systems, they take the piracy route to collect data and train their model through that. So that essentially results in a lot of problems in healthcare AI systems. So since we are talking to students from fashion design, product design discourses. So what would be a design philosophy to follow in terms of product design that would essentially embed ethical AI in its use case? My recommendation um, would be to not think about ethical AI from the get-go. You just have to address a foe or an enemy. This enemy is what we call in the design language of my company, Acme AI, as a disparity. Disparity is a challenge, a social challenge. It can be a commercial challenge. Why that challenge happens? The 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 framework you see on the left is essentially a human-centered design exercise protocol that was first popularized by IDEO. So IDEO.org, which is the same company that created the first mouse, the Apple mouse in the world. So they basically follow a very streamlined flow. So discover, ideate, and prototype. And I believe you guys are already in the prototype stage. What does this disparity mean, or what do they look like? We already talked about this briefly. For bovimetric, for the livestock weight detection system, the disparity was absence of weighing machine that proliferated the practice of guesstimation in the grassroots Bangladesh, and this proliferation was done by agents such as rogue paravets or that do not want to give out appropriate amount of services to smallholder livestock farmers. For Probahini, mass school dropouts were a big concern, as well as the stigma that happens in grassroots Bangladesh in terms of that was proliferated uh, by patriarchy. So and menopause is also akin to witchcraft here in Bangladesh, at least in the grassroots. So that is also a problem that we came up later on. Bovimetric is like, once we have identified that disparity, we essentially went on to create, look at opportunities where we can disrupt that disparity. So Bangladesh had a very good smartphone penetration and internet connectivity in rural Bangladesh. So we developed a smartphone based weight measurement system that works through cameras. The value that it provides is it gives out better economic outcomes for smallholder farmers. That's like the one-liner value. Similarly, for Probahini, we built a LLM-powered menstrual advisory chatbot, put them in an app because there is a good amount of WhatsApp users here in Bangladesh. So it was initially integrated in WhatsApp. And the value that it provided was on-demand information on menstrual management, putting a dent in legacy patriarchy and enable equal opportunity for girls. So the broadline health disparities that I could essentially give you an understanding of is to have, like, when you're in the process of identifying these disparities, look at it from a very broad lens. These are some of the things that I'm currently working on in Bangladesh. Mental health is a big case here in Bangladesh. We have only 260 psychiatrists to service a population of 19 million adult mental health patients. Impossible to do. Like that, essentially, you get one psychiatrist have to serve over 70,000 patients in a year. So that is an impossible odd for anyone to do, at least for the psychiatrist. In these cases, a system like a chatbot, a mental health chatbot, would essentially work very well. You have 48,000 community health workers that service 113 million rural population. We are embedding our Probahini chat, or we are at least in the talks of embedding our Probahini chatbot to this group of community health workers, enabling them to proliferate menstrual health education to the population that they serve. So 113 million population that they serve. So, and there it goes on and on. So, once we have identified like certain of these challenges, we essentially do a systems map. This is what a systems map look like. So because we were talking about health, we define service levels in the government level, in the facility level, in the community health worker level, household level, and the citizen level, and the kind of interventions that they get. We essentially then understand the area that is most prone to disparity, target our solutions for that area only. So a very niche product that we can later on expand on other use cases. So some examples in terms of AI in healthcare can be clinical diagnosis and imaging. So say, for instance, lung cancer detection. To detect lung cancer, you need to do a CT scan, a radiography, blood tests, X-rays, many other things. And you have to essentially go to a radiologist as well as a specialist to essentially get it vetted through them. It's a lengthy and frankly arduous endeavor for a patient to go through. What if you can have like diagnosis centers that you have access to anytime, go in, get radiography done, and get a confidence level understanding of whether or not you have lung cancers in a span of 15 minutes. That's real value. You're cutting down time and costs in terms of getting a prognosis for a medical use case. There are predictive analytics and population health use cases as well. So say, for instance, there are so hospital bed occupancy. We know like public hospitals tend to have very little, like very sparse space to accommodate the population. So say, for instance, if you want to go into the intensive care unit and there is no bed occupancy, you need to get into a wait list. Which hospital's wait list do you get into? If there is a prediction of the likelihood of which bed is going to be vacant in the next 24 hours, 48 hours, you have the decision-making power as a audience to essentially get into that particular like wait list. So these kind of examples are prevalent. There are certain challenges as well for these use cases. I just wanted to get you into this framework for our intended input on AI in fashion design. So this might be something that is more relevant to your industry. So what can be values that you can integrate? So you can essentially use AI-powered tools to create different patterns that is relevant to the global trend or fast fashion trends. You can also create fashion forecasting platforms that certain brands already use currently. But these are for very specific geographies. So not all geographies tend to have that. There are body scanning apps that essentially help you tailor make products or shirts or garments and deliver it to a person's home. Amazon does that in certain cases. There are smart textile cutting systems, predictive maintenance, particularly in the supply side of things. There are also AI optimized fabric recycling processes. So to essentially reduce carbon footprint, which is a connectivity between the global south and the global north, because brands of the global south would essentially want to reduce their carbon footprint under their ESG mandate, so environmental sustainability and governance mandate. And there are certain things that they want their suppliers to follow as well. So suppliers, say for instance, garment manufacturing company factory that is based in Bangladesh or Laos or Vietnam. So they have to follow those mandates as well. So AI can essentially work on making those supply chain tracking much more transparent, which is currently very human based. What kind of problem in terms of ethics can you see in these particular use cases? We are talking about the same examples here. So bias in fashion AI designs. Again, data set mostly designed for the global north or Western, as we call it. Western data sets are mostly there. There are gender binary assumptions. There are geographic concentrations or economic bias in terms of analytics and forecasting trends. So say, for instance, if you want to deploy a body measurement application, if your body changes in terms of a pregnancy, you're expanding and then reducing. You're not giving out like the proper size of that personalized fit or sizing to a pregnant woman in this case. So say for instance, there are issues of material misclassification, for materials that just do not exist in Bangladesh or Vietnam or Laos. They have to bring in those materials from somewhere else. And say, for instance, their supply sources are not very optimum, or that does not essentially accurately represent the buyer's demand. So that is also a problem. So there are supply chain, there are environmental impact measurement gaps. So how we essentially understand environmental impact versus how someone else from the global north understands environmental impact. So there are many biases that comes in terms of building these systems, these complex systems. These data biases essentially feeds into ethical AI. Uh, so we are closing to the end of our presentation. So just to give you a bit of a understanding and a bit of a truth that I realized working in this space for close to 5 years, there are very few global products in the world, very few. In AI, it's fewer still. So do not get bogged down. My personal recommendation is to not get bogged down with the doom and gloom that comes with discussing AI ethics, because it can be a very dark subject. So take the leap, make something first. Do not think about ethical AI initially. Identify a disparity, define your geography and your target audience. Uh, and most importantly, identify that first 20 friends and family that you are going to test your product on, and deliver tangible value. Ethics become important later on when you're scaling your product to a much larger geography, or a demography in this case. And ethical AI or building ethical systems can be extremely expensive. So that is something also to keep mindful of, because this translates into whether or not you're able to build an ethical AI system, or if you want to work in a niche that is appropriate for you. And then later, when in scalability use cases, you can essentially expand that into different geographies or demographies, provided funding is available. So I'm going to provide my presentation. There are some platforms that we have worked with other than the ones that we have described here. So this is a AI-powered video analytics systems. It's visualization system. This is something that we worked with using spatial data sets to automatically detect informal settlements here in Bangladesh. So informal settlements means slums. So slums they just pop up and pop back down again. And so it's very difficult to track them in Bangladesh, but there are people there that needs social services for the government. So it gets easier for the government to track them through this system. So this is a case of household aging and damage detection for a property insurance use case. It's based on North America. So my recommendation would be for you to start today using systems like Claude Code, Cursor, OpenAI recently released Codex. Build a prompt, give the system your prompt, build a system. At least a representation of it. And then for fine-tuning that system, there are many ways to do that. So possible future engagement avenues that I want to provide to the students that are here is that we are open to supporting you to fine-tuning any AI models that you build, or even co-design solutions, incubating novel solutions into an MVP, provide support in securing funding. So if you have something like that, don't be a stranger. Pop an email to my Sadhli Roomy at acmeai.tech. So if you want to, and we can have that conversation later on. And that's about it.